Good day, fellows. Setsu is back. Let me quickly introduce this concept of electromagnetism. Magnetism. You understand? See, we have two concepts. We have electro, which has to do with now electricity. I know that you know that the concept of electricity has to do with the flow of electric charges, you see, which are electrons to be specific. You understand? Then now we also have what? The concept of magnetism. Magnetism. This one is a phenomenon which is produced by the movement of electric charges. It is a phenomenon which is produced by the movement, bear this in mind, the movement of electric charges. You understand? The movement of electric charges. My apology about the light over there. Suppose if, let's say, I have a wire like this. Let's say if I have a wire like this, and inside the wire I have the movement of electrons, which is the concept of electricity. Somehow the very same movement of electric charges, which are electrons inside this wire, they are going now to produce this phenomenon, which is known as magnetic field. You see, we are going to get the magnetic field. You see, the magnetic field, which is given by a letter B or something like B. You see, then there we have a current which is given by a letter I, the movement of electrons. You see, they are going to produce what? The magnetic field around the given wire. Do you understand? Then now, for this video, we are going to determine the direction of what? Of magnetic field using the right hand rule. You see, we are going to get a situation which is like this now, which is like this. It's like now if I were to give you a situation which is like this. Suppose if this one, it represent what? The current which is moving out of the page. Somehow, let's say it's moving out of the page. You see, it is moving out with a dot, out of the page. You see, let's say this dot, it represents the movement of electrons out of this page. You see, then now I want you as a learner to determine the direction of what? Of magnetic field around this given what? Wire, which now it is represented in a form of a dot to show that the electrons, they are moving out, or the current is moving out of this page. Do you understand? Then now we are going to use the right hand rule. See, let me draw something like this. see, we are going to use the right hand rule, whereby now our thumb will be in the direction of current, then our curled fingers will be in the direction of what? Of magnetic field. You see? Then on this given situation, we say now the current is moving out of the page. I'm going to have a situation which is like this. You see? Then the curled fingers will be like this. You see, the current is going to move out of the page, but as for magnetic field, they're going to move like this, anti-clockwise. You see, I'm going to get a situation which is like this. The current is moving towards us, you see, but as for the magnetic field, it's going to turn like this. I hope you can see, turn like this. Then we are going to get a situation which is like this for the magnetic field. Then that dot is going to represent what? The movement of current or the movement of electrons. Do you understand? Then now, what is going to happen if I were to give you the situation which is like this now? See, let us determine the direction of what? Of magnetic field. Now we get a situation whereby the current now is moving towards or inside the page or towards the page. See, it's like now my thumb is going to face like this, then curled fingers, you see, I hope you can see over there, then it's going to be clockwise, then the direction of magnetic field going to be clockwise like this. Do you understand? I hope you do get the picture, because now if I were to turn my thumb like this, look at my curled fingers, they are going to move like this, which is clockwise. See, then over there we have the current which is moving towards the page. Do you understand? Now let me proceed. Suppose if now I were to give you the wire like this. Let's say if we have a wire like this, then we have the current which is moving upward like this. Then how then are we going to determine the direction of magnetic field? Bear this in mind that when we draw a dot like this, we see that this dot, it is moving out of the page. When we put an X like this, we say that something is moving towards or inside the page. You see, this one is out of the page, this one is towards the page or inside the page. Do you understand? Then now, by looking at this diagram, we have two sides. We have this side as well as this side. You see, we want to know that how then are we going to represent the direction of magnetic field for this was and this side. See, then it's so simple. Same again, let us use our right hand rule, which says the thumb in the direction of what? Of current. Then the curled fingers like this in the direction of what? Of magnetic field, like this. You see, we have magnetic field like this. Bear this in mind. I'm going to put my hand like this. Then this side, the magnetic field is going to move towards or inside the page. You see, this side, the magnetic field, they're going to move inside the page. But on this side, if I were to curl it like this, they're going to move out. You see, if I were to turn it like this, it's like if, let's say, I have a marker like this, then I put my hands, you see, they're going to move out this side, out. The magnetic field going to move out of the page. As we go further, they become weaker. You see, as we go further, they become weaker and weaker. You see, then this side inside the page, then this side out of the page. Then we have the current which is moving out, sorry, upward like this. Do you understand? Then on this one we had what? The cross section. Then we had, then previously we had the front view, which is like this. If the current is moving out of the page now, like this, then we got the situation which is like this. We have the front view, something like this. We got a situation which is like this. On this one we have the side view, you see, whereby now the current is moving from downward to upward like this. Do you understand? I just wanted us to make some difference between the front view as well as the side view like this. I hope you got the idea. Then now, how then are you going to draw the magnetic field around this coiled wire? We call it a loop. Let's say now if I were to give you a loop like this, see, let's say if the current is moving down this side, up this side like this, like this. Let's say if we have the current, this one is the current, you see. Let us determine the direction of what now? Of magnetic field. See, then we are going to approach each of these given wire using this given marker. You see, I'm going to do it like this. Then on this section, I'm going to get a situation which is like this. Then the direction of the current will be upward like this. Then this side, the magnetic field is going to move towards the page. Then as I do like this, then going to get a situation this side which is out of the page, this side inside the page. Do you understand? Then let us try this one. Then I'm going to get a situation which is like this. The direction of the current, there's my thumb. Then the this one don't be easy for me, but bear this in mind. This side I'm going to get a situation which is out of the page. You see, out of the page. Then this side is going to be in a page. Then this side is going to be out of the page. At the end of the day, I'm going to get a situation which is like this. Do you understand? Then let us try this one. You see, it's going to be difficult. This one is like, now if I were to put it like this, check on this side, I'm going to say towards. This side is going to be towards, like this. Then if I, difficult for me to, you see, like this. If I flip it like this, then the current this side is going to be out of the page like this. You see, I hope you do, and I hope you do see this thing I'm trying to explain. Then for this one, it's going to be much easier. Then the direction of the current will be like this. You see, then this side we move towards. You see, towards, it's X. Then this side is going to be out of the page. You see, then this is going to be the direction of what? Of magnetic field. Outside we get a situation which is towards. Inside we get a situation which is out of the page. You see, I was trying to make it easy. I hope you got it. You see, then now lastly, let me explain this one of a solenoid. You see, then a solenoid, it looks like this. It look like this. We have so many coiled wire. See, like this. Then now, as for solenoid, bear this in mind. As for solenoid, our curled fingers, they are going to represent the direction of the current. Then our thumb will be facing on the knot of what? Of the magnetic field. I hope you do understand. Then, only on the solenoid, my curled fingers will be in the direction of what? Like this. My curled fingers will be in the direction of the current. Then my thumb will be facing on the north side. This one is going to be my north side. Then this one is going to be my south of what? Of the magnetic field. Then somehow the magnetic field is going to be like this. See, this side towards. Then only for what? For a solenoid. Then I'm going to get a situation which is like this. I hope you got the picture over there. You see,